Welcome back, learners. So now let's move on to the next kind of model, which we call it as Poisson regression. Fine. So we call it as Poisson regression model. So here what it is different. So here also you have something which is called as response variable. The other one we call it as predictor variable. So all the models from the beginning we had seen linear, we had seen multiple, we had also seen logistic. Fine. So in all these, even including your Poisson, you will have response variable as well as predictor variable. So in case of Poisson regression, how it will be varying. So in case of Poisson regression, your response variable will be in the form of counts. So it is counts means, now suppose I say I want to know how many times a student has got first mark, or I say how many times a player has won the match. So if suppose you have a variable which is going to represent a count, in that case that will be considered as a response variable, and you can go for modeling it using Poisson regression model. Fine. So the remaining predictor variables can be anything, need not be a count, it can be any numeric or a fractional number. But in case of Poisson regression, the response variable has to be in the form of counts. So this is what is the basic for your Poisson regression model. Yes, fine. So as your other regression models, the Poisson regression model follows the response variable will be of equation log of y is equal to a plus b1 x1 plus b2 x2, and it keeps on going, that is bn xn till this. So this will be the mathematical function based on which your Poisson regression model will work. Okay, yes, fine. So what is going to be the function which will help you for designing your Poisson regression model? So we had seen this GLM. So this GLM we had seen in your logistic regression model. So the same GLM function can be used for Poisson regression model also. So it will take the same three values. So one is the formula, the other one is the data, and finally the family. So how it is going to be different? So here the formula as well, the same scenario, response variable followed by your predictor variables. Data is going to be the subset or the whole data which you are going to consider, and family, in case of logistic we had a family which is binomial. In this case it will be Poisson. Fine. So this is what is the difference in your GLM function. So only the family will vary, all the remaining is going to be the same. So in case of logistic, the family was a binomial. In case of this Poisson regression model, the family is going to be Poisson. Fine. So this is the syntax for your model. So now for this demonstration, for going for generating this Poisson regression model, we can't use this empty cars. Fine, because there you don't have anything which will say these many cars are produced. Suppose you have a data frame which will say that in this year these many cars are produced, in this year these many cars are produced, something like that. Suppose I say Maruti, these many cars are produced, Innova, these many cars are produced, and these many cars are sold, something like that. So if it is going to be a count, you can use it. But in case of empty cars, we didn't have a count kind of variable, so we can't use it. So there is another something which we call it as warp breaks. This is also a built-in data set which is available in R. Fine. Similar to your air quality, your empty cars, you have this as well. So now let's use this. Now let me check out what it is printing. So I say warp breaks. Fine. Yes. So this data set, now you can see you have three columns in this. One saying breaks, one saying wool, the other says tension. So what is this data frame? Let me first explain you what this data frame is. So you have breaks. So this column says how many times there is a breakdown. Fine. So this is a count. It says 26 times. 26 breakdowns. This is 30 breakdowns. Fine. And for wool, so this wool can take either a value A or uppercase B. Fine. So this says the type of wool which is going to be spin or which is going to be manufactured. And the tension says what is the tension on that loom, whether it is low, medium or high. Fine, it will be L, uppercase L, or medium for lower uppercase M, then high uppercase H. Fine. So how do I know it? So you can check out the structure of this. See, I can say structure of warp brakes. Fine. You can see here there are 54 observations of 3 variables. Fine, only 3 variables. One is brake, the other one is wool, then the tension. You can also try out how do I know this? That is how I am showing you. Now I say brakes, it is just a numeric value, so it has some count here. Then wool, see, it is already a factor. It is not integer or a numeric variable. It is already a factor. It says 2 levels. It can have either A or B. And again, tension is also a factor which has 3 levels. It has low, medium and high. Fine. So this is how it is distributed. So you have 54 observations, which means 54 rows are there, 3 columns are there. So that is what is 54 observation of 3 variables. So this is how you can interpret what is your data frame and stuffs. Based on that, you can decide your model. Okay, fine. So now since you have the response variable, now I say brakes. So this brakes is a count. Fine, it is in the form of count. So I can use this brakes as a response variable for my Poisson regression model. Okay, so based on the remaining 2 variables. So now let's go for designing it. Now I say model Poisson is equal to, see, since this is already, this wool and tension are already factors, I am not converting. Otherwise, like we converted in the logistic regression session, we converted that rank into a factor, right? Similarly, you have to convert it and then you can fit your form model. Fine. So here it is already a factor, so I am not converting. Now I say GLM of, now we have the response variable is brakes followed by the symbol for formula, then you have wool plus you have tension, yes, and this is your formula. Fine. So the variable here, the argument is a formula, so formula is equal to this, and I say data is equal to, see, I am going to use it as such completely, so I say warp of brakes. Fine. So warp brakes followed by family is equal to, as I said, if you have to go with Poisson regression model, your family has to be Poisson. Yes. So now my model is created. Now let me print this summary of the model and let us check whether it is fitted properly as we did for our logistic regression. Yes. So now you can see here, so see this last column, you can see everywhere you have 3 stars. So which says now this is lesser than 0.05. All these values are lesser than 0.05. Okay. So it says will be tension M, tension H. Okay. So what does it mean? Because we are fitted with saying that A, L and stuffs. It is saying for these, all these values, this you can have some impact over it. Yes. Fine. So now your model is ready. So with this model, you know how to predict. Fine. So you can predict. Now I can say predict. What was the name of the model? I think it was model underscore Poisson. Let me check before that. Yes, model underscore Poisson. And now I say my new value. So I say data frame and I say wool is equal to, suppose I say B. Then I say tension. Yes, so tension is equal to, suppose I say M. Fine. See, I've got some value which is going to say these many brakes. Yes, and this says 3.16, so it is approximately some 4. Fine. Yes. So now this need not be the right accurate number of brakes. See, there is something which you can fit further. So that and all is a bit advanced level that is not required for you now. So you just get to know that this is what is a Poisson regression model. So in Poisson regression model, your response variable should be in the form of counts. Yes, all the remaining predictor variables can be numeric or can be a fractional number, but your response variable has to be in the form of counts. So with this, you can go for with your Poisson regression model. So the important stuff you have to remember here is everything has to be whichever, if you have some categorical variables or a factor kind of levels, it has to be a factor. Otherwise you need to convert it into a factor as we did in the previous logistic regression model. Okay, yes, and the family here has to be given as Poisson. So these you have to have in mind. So you can work on with few other examples, available data sets, or you can create your own data set and you can work on. Yes, fine. If you still have any doubts, you can very well contact me. Thank you.